Welcome back to Advent of Code 2025, day 5. We'll be opening, the problem will be opening in a couple of minutes. Just open my files. All right. All right. So, day 4 was a nice, easy problem. Easiest of the lot, I think. A lot of people found that. So maybe we're expecting a hard one today. All right, here we go. $30. Jane Street. I applied to them once. I failed the interview. Had a tough binary trees problem. Balanced binary trees, something. Oh, keep an eye on the calendar. 765. Off we go. Cafeteria. As the forklifts break through the wall, the elves are delighted to discover that there was a cafeteria on the other side after all. You can hear a commotion coming from the kitchen. At this rate, we won't have any time left to put the wreaths up in the dining hall. Resolute in your quest to investigate. If only we hadn't switched to the new inventory management system right before Christmas, another elf exclaims. You ask what's going on. The elves in the kitchen explain the situation. Because of their complicated new inventory management system, they can't figure out which of their ingredients are fresh and which are spoiled. The database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and a list of available ingredient IDs. The elves are trying to determine which of the available ingredient IDs are fresh. Oh, I see. So it's a range finding method, for which there are many kind of algorithms and data structures, but in this case it looks like it'll just be Oh, I see. Okay, fine. I mean, I think just checking each range one by one will be fine here. You can make a well, you can do binary something or other to. All right, let's just get this code input processed first. All right. So. So there's up to 1,000. I think we could just do a search one by one. Check if it's in each number's in the range. So let's line in f.read lines. Um. Okay, so let's say ranges equals a list. Okay. If, let's say, the hyphen in line left right equals line dot strip. You don't actually need to strip here. Dot equals int x or x in line dot split on the hyphen. Okay, so ranges dot append LR. So we'll just put it in a list for now. We could sort by... It doesn't actually matter. No, we'll just leave them in the order. Okay. Elif line dot strip, so it's just a blank line. Else so we have an int. All right, so let's just take these out of the loop. Okay. So just do a straight up double for loop. Let's see if that works. I think it should. For in ingredients for if, so it's inclusive. Let me go on to the next one. Why doesn't it like this? Well, ranges is pairs, so why are you complaining? Okay. 638. And that was pretty fast, so... Correct. Alright. That was pretty quick. Alright, part 2. The elves start bringing their spoiled inventory to the trash chute at the back of the kitchen. So that they can... Only 52 people so far. Okay. So that they can stop bugging you when they get new inventory. The elves would like to know all of the IDs that the fresh ingredient ID rangers consider to be fresh. The ingredient IDs that these... How many ingredient IDs are considered to be fresh? Oh, okay. Alright, this is what I thought might end up being the case. Okay, I know how to do that. Alright, so we want to basically just compute. First, we need to make what is it called? Like a range data structure. Alright, there's efficient ways of doing this, but we don't need to be too efficient, so let's say disjoint ranges. It's a long-winded name. For LR in, so we could use binary. We should be using binary search in several places, but we probably don't need to bother. Okay. Alright, so we're trying to insert this range into our list of disjoint ranges. But, alright, well, there's different cases we've got to look up. Well, let's first write some helper methods here. So we want to define range intersect. Well, no. Ranges intersect. So we just say L1 R1 equals R. Oh. Okay. So it intersects if either L1 or R1 lies in range 2, or L2 or R2 lie in range 1. That's how you prove that they intersect, right? Yeah. One of the endpoints must be in the other range. So if, or just say return L2 is less than or equal to L1 is less than or equal to R2, or so R1, oops, 1, or okay, so if ranges intersect, this is a method. P in ranges. If ranges Alright, so we've got a range. We're trying to insert it into our disjoint ranges list. So we've got to check through, and they're sorted in order. So for it could intersect multiple as well. Oh no. Okay. Oh, there's a no. There's a better way of doing this. What is it? I forget now. Oh, you sort by the right hand point of the ranges. Right? So if we do that, so we first sort the ranges according to the right hand end. If we do that, then we ensure that we only overlap one range at most in this list. Yeah? Is that right? No, it's not right. Oh man, there is a clean way of doing this. I forget now. This is a classic coding competition problem. Like there's all kinds of techniques for doing this in 2D and 3D and KD. It's something like along these. Yeah, we want to sort something according to endpoints or something, but I don't remember exactly. Oh no, the other way around. We sort it by the left point, right? Yeah, then we know it won't intersect multiple ranges, just one. Yeah, because you've inserted a bunch of ranges, and now you've got a bunch of disjoint ranges. But the left endpoint of the final range, that the latest, or the rightmost range in your list, that was the most recent thing that you inserted, or sort of. Well, that is an endpoint. That is an event point. Let's call it an event point. So you can't. So the new range you're inserting must have an event point later than that. Okay, I think that might be it then. So let's say sort on. We don't need to specify because it will automatically sort on the left. What are we doing? The left number before the right number. Yeah. Okay, so we're good. And it probably helps to sort on the right number as a tiebreaker. Well, it's probably no ties. All right, ranges.sort. All right, okay. Now we say for D range in disjoint ranges. So now there should at most be one range it intersects with. P with D range. So if it intersects, now we need to find the union. Also, we need to be using iterator. Oh, but we're gonna have to modify our bollocks. Let's just figure out this union method. So return. So it's just going to be like the minimum of L1, L2, and the maximum because they intersect. So we just want to take the full range that encompasses both. The problem is this is a null range here. We want to get rid of it, but we can't modify. Okay, so new range equals ranges union P That's what we're inserting now. What, how am I trying to... Okay, so we can't just delete that range. We're just gonna have to mark it or something. So let's say we break because we don't need to do anything more after that. Else. So if we go through that loop and we don't find anything, we'd never break out of it, then we can just put P on the end of the list. It doesn't actually interfere with anything. It's a disjoint range. We just want to have ranges that don't overlap. But if we did find something, you know what? We should just put some booleans here because did overlap equals false. Did overlap equals true. Break. Okay. So if did overlap. So if it overlapped, then we have I pointing to where it overlapped. So we delete disjoint ranges I, because that's the one we want to get rid of. I'm going to replace it with the new range. Right, I'm feeling a bit... This feels all a bit hacky now. I'm not sure. I might have to look up what the technique, the usual technique for this is. Hello, DJ. I think it's going alright. I guess I'll try it now and see if I've solved it. Did overlap is true. Break. If did overlap, we append what we just made. Otherwise, we just append the original range. Alright. Then what? So, after that, let's just see if we actually get this far without any crashes. So we've got a set of disjoint ranges, hopefully. And they should be, like, in order. Okay, so that looks like it's fewer than the ranges we have, so there's a lot of overlap. Alright. So now... for LR in disjoint ranges, result 2 plus equal R minus L plus 1. That should be the number of ingredients in that range. And print result 2. Okay, let's try that. Correct. Okay. It worked first time. It felt a bit hacky, but I think that's what you do. That's the trick, to sort by... Okay, so now I'm thinking back to my university days. This is normally phrased as a event scheduling problem, I think, where you have a bunch of events which have start times and end times, and you're trying to fit them into a schedule, so you have a time slot or something like that. And the technique normally is to first sort by event point being basically the start of an event or an end of an event. Sort your list according to event points. Of course, what I did wasn't really the best, wasn't really the optimal way, because I was doing a lot of for loops. What you should be doing is using binary search, because at every stage you've got a sorted list. Like our disjoint set was sorted. You use binary search to find the insert point for where you want to insert your new range. Oh, wait. Hang on. No, you don't even need to do that. The only range it can possibly intersect is the last one. The one at the end. Because of the sort. So if it intersects... Ah, wait. Wait, let's have a look at the stats. Okay, we're in the top 2,000 or so. What we should be doing, hang on. This for loop is redundant. What we should be doing is... if ranges intersect P, and we should be checking the last thing that is in disjoint ranges, except it might be empty. So if disjoint ranges is not empty and and it intersects the last thing, then new range equals that. We don't need this. So we say delete -1 and append, or we just replace it in place. So we just say void the delete. This range is -1. We can. You should avoid using delete if you can, because it's an inefficient thing normally. We can say this joint range is -1. Can you do this? I don't know if that is a valid. Yeah, probably. Yeah, -1 is a valid pointer to a, yeah, okay, so is new range. Else that. So we don't even need to do that for loop, so do it like that. Is that the same? Three, 3, 8 at the end. Yeah, it is. Okay. So it all really came down to this line here. Sort your data, which is an important lesson. There's a surprising number of things which become easier, much easier, to almost trivial sometimes, when you pre-sort your data. You just have to think about how you want to sort it. In this case, which is the default sort is actually the right one. Okay, that was a good problem. It was a classic. That was basically textbook range. Let me look this up. It's like 1D, one-dimensional range. Inserting intersections algorithm. I don't remember. Interval tree. So this will probably be overkill. But I think it's the ultimate way to do it, really. If you know that the only thing you want to do with this data is okay, this is if you want to do more than what we're trying to do, but it's mostly just oh, well, that's definitely a faster way of checking if they intersect. I think we... Oh, yeah. Well, it's pretty much the same. It's not what we're looking for. Alright, well... Later I'll have a look at people's solutions. Maybe someone's explained the classic algorithm that this is usually referred to as. Alright, well that again only took about half an hour, although that was like definitely that is considered a harder problem than yesterday's, but it helps if you've seen it before a billion times. I probably have. It's a classic, but thinking about it from first principles is a bit harder, because you can end up doing something a bit complicated where you're trying to overlap multiple ranges, and then you have to write like a method which unions the whole lot. Hello, level 27. How is -1 not a buffer overflow in that context? I know Python's different, but that seems like strange syntax. I think -1, so Python translates indices using modular arithmetic. So if you give a -1 or -10 or -1,000,000 or something, it will do modulo the number of things in that list and then point to that location. So -1 will translate to length of list -1. So it helps when you're writing ranges which go backwards or forwards or cycle around a list. Hello, Temporalis. Just solved the problem. How are you enjoying Advent of Code this year? It's pretty good. No particularly tough problems yet. Yesterday's was very easy. Today's didn't take long, but it's arguably a bit harder, although I've seen this problem many times before, so it wasn't too hard. It's a classic range intersection data structure type problem, which doesn't really need the most complex solutions involving like binary search trees or anything. It's, I think, just a sorted list is really all you need. But I think the hard problems are yet to come. I mean, we're almost halfway through the month, the calendar, so we could start getting some hard problems soon. All right, some people are still working on part 2. I guess Umaro is as well. All right. Captain Coda. Temporalis here has done it as well. All right. This is definitely something I remember coming up in computational geometry, which was like my main research focus back when I was doing a PhD. Like anything involving segments, line segments, and particularly this kind of thing can be extended to 3D because you can have squares or rectangles which overlap, and then or n-dimensional shapes which overlap. So the algorithms we use here can naturally extend to multiple dimensions. I did a cursed n-squared implementation. I mean, yeah, I could see from the data that n-squared will happily work. Each range to every other range. Oh right, you did the full range per range. And then what did you do when you find a match? So were you actually ultimately trying to compute a set of disjoint ranges that encompass? Check if the ranges overlap and then save that new range. So the new range being the union of all the overlaps. Okay, yeah. Okay, fine. Yeah, I guess that's not too different from what I did. It's adding one more for loop, essentially. And that's pretty much what I was coding at first. Then I realized if you sort according to the left endpoint of the ranges, then you wouldn't ever need to, because it can only ever overlap the last thing in your list. But yeah, that one extra for loop wouldn't really add much. Oh wow, it's only 188 ranges. Okay, yeah, that's actually quite small. That makes a lot of sense. Yeah, that's the trick, because this problem, it used to be a classic in coding competitions back when coding competitions were more popular. And there was always some trick involving sorting, and it's usually like sort according to the left endpoint or the first event point or something like that. But yeah, so in my basically I did have a for loop here which was doing that, but then I realized you can just because I've sorted it like this, and it's the default sort anyway in Python because it's sorting to the left value, then I just check against the last disjoint range. It either overlaps or it doesn't, basically. I guess this is... I mentioned some stuff involving binary search trees and stuff, but I guess this eliminates the need for those, given that the only query we want to do from this point on is just summing up the lengths of all these ranges. If you wanted to do more stuff later on, then you probably want to use one of those interval trees or something that was mentioned on Wiki, but this is efficient, isn't it? Because it's literally just it's constant time to remove and add at the end of this list, and then interval trees are more for online queries where you're getting a stream of data. You don't have the chance to sort it. You get given a range at some time and you want to insert it efficiently. At that point, yeah, you would need something like either you'd basically have to do what you said. You'd have to check all the overlaps, because if you're getting streaming data, then you don't have the opportunity to sort beforehand. Something like an interval tree in a previous year. Yeah, oh yeah, I'm sure it's... There's lots of interesting things you could do with it. Even in like multiple dimensions. Okay. Who is still going? Let's have a look.
%90 of the time.
Cop, I've raided Alka, I've raided Stew Squared, I've raided Rascal 2. Is that... What language is that? JavaScript? Alright, let's raid Rascal 2. Alright, that's it for today. I'll try to... tomorrow might be about an hour late or possibly longer. Might not be able to do it on time. Around the same time, I'll be back tomorrow. See you next time.